subir el volumen? ¿No? Bueno, vamos a empezar entonces. Gracias a todos por venir. Estamos muy contentos en la facultad porque tenemos una celebridad que nos visita, Val Johnson. Bueno, mis alumnos y los demás saben que el tema de Patrones ha sido revolucionario en la Ingeniería de Software. Gracias a los patrones de diseño hoy nos comunicamos diferente, ¿sí? Tenemos otra manera de comunicar nuestras ideas, nuestros diseños, de enseñar programación orientada a objetos y todo lo demás a lo que los patrones han llegado. Así que, bueno, les voy a dejar rápidamente con él. Al final, la charla va a ser en inglés, pero si quieren hacer preguntas en castellano, se las podemos traducir. ¿Sí? So, thank you so much for your generosity to come to Argentina and to La Plata, to our university. We're very happy. Thank you so much.
I'm happy to be here. I had never been to Argentina before. My birth certificate, or rather my passport, says I was born in Panama. But I left Panama when I was 2 months old and never came to Central or South America again until 2 years ago. I went to Brazil, and so now I'm in Argentina. And I had a very good time. I was in Tucumán for last week during the Smalltalk conference, and had a very good time there. But I'm here to talk about design patterns. The copyright on the book is 1995, but the book actually came out in October of 1994. It was at an UPSLA conference, and one of the things I learned is that booksellers like to play with the date because they want people to think that the book is a little bit newer than, at one point they were concerned about making this book look new. It's very funny now, but of course nobody had any idea at the time that the book would last as long and sell as well as it did. Now there are 4 authors. These bananas now in order, but it really was Eric Gama's idea. He had some patterns in his thesis, his PhD thesis. He had been looking at framework design, and he came to a UPSLA workshop and told people about them. And I was one of a number of people who really liked the idea. We thought that was a great idea. I had actually been writing papers about patterns. So the other 3, first Richard was working with Eric, and then John was working with them, and I was the last one to join the project, but I had already published papers on patterns. I think they wanted somebody who was a little bit more known to join the project. Anyway, it's won lots of awards, and I do not think it is a programming language book. It's definitely a design book. So software engineering, it fits in a little bit better. Programming language, I didn't quite understand why we got an award for that, but I was happy anyway. There have been many books that have been written based on it, or because it was written, lots of other books have been written. Now some of them are just taking the exact same patterns and trying to recast them or explain them from a different point of view or for a different programming language. So the very first book was the Design Patterns Smalltalk Companion. These 3 people were at IBM, and they all were using Smalltalk. And the Design Patterns book is mostly in C++, but there's some Smalltalk there as well. I wrote all the Smalltalk in the book. I was a Smalltalk person. And they thought that we needed a book that would really be ideal for Smalltalk people. And there have been books on Visual Basic and Ruby, and you name it. There has been a book taking our patterns and showing how to use these patterns. Because although we claim that these patterns are not language specific, that they're patterns that you'll find in all different programs in all different languages, still the language changes the patterns. The languages do have an effect on the pattern, and so you can know how to do it in one language, and when you move to another language, you have to experiment a little bit to see what's the best way. And sometimes a pattern that works really well in one language doesn't seem to work nearly as well in another. I'm going to be talking about that some. The Heads First design pattern is a Java book that's pretty recent, and one of the books that I most enjoy reading, often when I read a pattern book and for some other language, that looks reasonable, but I don't learn much from it. This is a tutorial, and they try to explain how each pattern illustrates certain design principles. And I really like that, and I wish we had done that in the book. Of course, at the time we wrote the book, we didn't realize exactly how the patterns illustrated design principles. So we couldn't have written the book that way back 22 years ago. But it's very good. There are other books that are about completely different topics. They're not about our patterns. They're about different patterns. And one of the things that our book did was encourage people to talk about concrete designs. And most of you, many of you were not alive then, but and those who were not thinking computer science thoughts back then. But the world was a different place 22 years ago, and one of the things was that people didn't talk about concrete design. But you do that for compilers and operating systems. So for certain areas that were considered academically respectable, people would talk about concrete designs. But for most areas, we didn't do that, and so the patterns have been a way for people to do that. And Eric Evans' book is more about if you're building business systems. We always talk about having a domain model and trying to make the application, the design of the application, match the problem domain. And so if you're talking about banking, then you want to have a bank account and customer objects and so on. So you want to use the language of the customers. Well, he actually says it's not quite right. You don't use the language of by customers. Customers of your system, people who are building the system for. You don't just ask them, what's your language? Because there will be words you will need to use talking about a computer system that they don't necessarily have when they are dealing without computers. And so you will have to invent new vocabulary, and it should be a joint project between the computer people and so he goes a lot about how you really design a system to match a problem domain. That's really that book. And then Martin Fowler, of course, has actually done several different pattern books, and this is one of this one is much more about object-oriented building a big system in Java or some other object-oriented language. Okay, so the book is clearly a success, and to say that it wasn't, and we should have done something different is it's sort of hard to say that. But on the other hand, as time goes on, I can see more and more things wrong with the book. And people have been asking us ever since we were getting close to the 10-year anniversary. The question was, well, it's been 10 years. Shouldn't you do a second edition? And people have been continuing to ask that question for a very, very long time, including my wife, who's sitting in the back. And so as part of motivating myself to work on that, I've been collecting things that are wrong in the book, things that we see. And so that's this. I'll be talking about a few patterns. I could actually do this. I think I probably have about a day's worth of material now. So I'll just do a few patterns. So why does the book give bad advice? Well, sometimes it gives bad advice because things have changed. It was actually good advice for 22 years ago, but it's not good advice now because we have different ways of doing things. So sometimes that's what it is, and it's hard to feel guilty about not being able to predict the future. Nobody can predict the future very well, so that's what we say. But there are other ways where, as I look back, especially in the Smalltalk, I was talking to the Smalltalkers this last week, and I can remember Smalltalk systems that were doing things differently in 1980, probably 81 or 82, certainly by the 90s, they were doing it differently. And yet we didn't talk about it. So we could have predicted, because we had examples of that. But one of the things the book has is 3 different categories. It divides up the 23 patterns into 3 categories. And people often seem to think that there's something profound about these categories. There is not. We looked at a list of 23 and said, that's too long. We cannot have a list of 23 things. People hate lists that are so long. We have to break it up into smaller lists. And at one point we had 6 lists. We had some sort of theory that would tell us that we could put them in these 6 lists, except one of the lists had no patterns in it. So that wasn't very, very useful. So anyway, we ended up with these 3 lists. And we were pretty happy that they fit the patterns in the book reasonably well. And the creational patterns are a really nice category. You can pretty much tell this pattern is going to be creational, it's not going to be creational. Structural and behavioral, not so much. There are patterns where you could argue that it's structural or behavioral, and you could argue either way. But when you're doing a book, you have to make decisions, and it worked okay for the book. Now, we had a meeting a long time ago. I don't remember exactly how long ago it was, but we were talking about doing a 2nd edition, and one of the things was we didn't like this categorization. And we thought a more useful categorization would be to separate patterns into core and peripheral. Core being the ones you want to learn first. These are the ones you're probably going to use a lot. Versus peripheral, which a peripheral pattern might be really, really important for your system, but the odds aren't so good. Now, you don't see them all the time. They come up every now and then, and that's fine, but we couldn't say that when we wrote the book, but looking back after many years, we can tell these are the patterns that just show up all the time, and these other patterns are less common. We also were thinking about some of the patterns, which we had a little problem with. We decided it was actually because they were compound patterns. They were actually combinations of other patterns, and if we thought of them as combinations, it helped. And then the creational patterns were actually a good category. So these are the ones we thought of core. I often sneeze around chalk dust. I'm not sure if there is chalk dust. But actually, I think there is chalk dust. Maybe that's what's causing it. We also decided we were missing no object. We thought no object should be a core pattern, which was like, how could we have missed that when we get to the book? It's such an obvious, easy, simple pattern that you see all the time, but it never occurred to us that that was a pattern as well when we were writing the book. So that would be on this list. So I'm going to talk about composite, iterator, observer, and I think I mentioned mediator too. Okay, so the observer pattern. So in the book, every pattern starts off with a very brief description called an intent. And this is the intent for observer. Define a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. Now, the thing about all these intents is that if you read it and you understand it, you say, oh yeah, I think I know what that is. Well, then you probably do. That you probably don't have to read the rest of the chapter because, but in fact, most people, if you're new to a pattern, you'll read it and you'll say, what is he talking about? and you have to read the chapter. In fact, that's a problem. It's hard to know how much work it takes to learn a pattern because you may have seen it before. You just didn't know it was a pattern. And so it doesn't take very much for you to read and then suddenly you see, oh, that's the same thing as in this program that I worked on, and then you start to understand the pattern. Or, if you have never seen it before, then you read all the way to the end, and you're glad that we have several examples, several code examples, because every time you read it, it makes a little bit more sense, a little bit more sense. The sad fact is, people have often talked about, in the early days, people would talk about how wonderful patterns were, how they were this sort of condensed wisdom, and you could read these patterns and acquire the experience of the ages. The fact is, you don't actually learn a pattern by reading a book. You learn a pattern by practicing. And the book is great because it tells you what to practice, and it gives names, it gives standard names. And the book is very useful for the experts on it, because they could just read the book and say, oh, I know that one, I know that one. Now these are going to be names I can use. And then they could use those names to communicate. I've heard of consultants who told me they really liked the book because they would tell people, do this, and the people would argue with them. And now they have a book, they open up the book and say, do this, and people read, okay, and it's easier to convince people what to do. And then also, a problem with patterns is you read the book and it makes sense, but you're not sure, should I use this pattern on this project or not? Well, the way that you learn when you shouldn't use a pattern is by using it when you shouldn't. And of course, that costs something, there's some pain associated with that. And so it's sort of nice to have an expert who can come in and say, oh yes, you should use this pattern here. And then you can be much more confident and you have better experience that way. But again, this is sort of a language for communication. So the observer pattern, there are subjects and observers. There are two roles. And in our book, we talk about them as being classes, but they really are roles rather than classes. And that's true of a lot of the patterns. We use the terminology of classes, but often they really are roles. And here I'm using Smalltalk words. This pattern is built into Smalltalk. Every object in Smalltalk has both subject and observer protocol because it's a class object that defines them. Now, you don't actually want every object to be a subject and an observer, but it is built into the language, or the library, or the class object. So the subject is the object whose state is changing. And the observer is the object that's supposed to be notified, and is going to react when the state changes. So the subject has operations of change, we call it change, and that means the subject has changed its state, and then it will send the update message to an observer, and that is notifying the observer that the subject's state has changed, and the observer is supposed to do something about it. And in Smalltalk, this is called the dependence mechanism. That's the standard name. And so I sort of like the fact that we use dependency. We said dependency there, so the Smalltalkers would feel at home. But one of the things about most of the patterns is that we gave name to the pattern to one object in the pattern. And I actually don't like that. Looking back, I think that's a bit of a mistake because the pattern is a whole thing. The pattern is as much about subjects as it is about the observers. It's not, you could have called it the subject-observer pattern, except that often you have some outside agent that's going to be working with them. And when you, sometimes somebody has to send the change message, and it's another object that's causing the subject to change will actually send the change message. So that object's not in this picture, but that object's part of the pattern too. Okay, so when you use the observer pattern, and so I have down here an example of using the observer pattern. This example is that we are simulating a 1920 mobster movie. And so we have the FBI that is observing, spying on these mobsters. So classic is the lookout in the hotel room across the street with binoculars. They actually sometimes use really high technology. There's this really new communications mechanism called the telephone. And they had discovered hacking techniques where they could buzz the telephone line and find out what people were talking about. That was really the innovative technology of the 1920s. And so they had other ways of observing and they would want to know when these mobsters were going to rob the bank or go to drive a getaway car for something. Now, if you're programming this, the way you program this, according to the observer pattern, is that the subject actually has a list of observers. So an observer registers itself for the subject. It has operations like add dependent and remove dependent. Now, what this means in your simulation of FBI agents and mobsters is that the FBI agents have to notify the mobsters that they're being watched. And which sort of spoils the idea of the simulation. But that is, in fact, exactly how the observer pattern works. That's exactly how the observer pattern works. So the way that in practice it works is when you make a subclass of subject and you're implementing all this mobster behavior, you don't actually ever access your observer. You don't ever write code that knows about the observers. You just have to write code that says self-change. And that calls a change operation. And then everything else will work properly. And you try to forget the fact that every mobster is keeping a list of all the FBI agents that are watching it, and it just goes along with it. You just don't want to think about that because that spoils the simulation. But that is actually how it works. And I like to think about this because of the fact. Now, this has a lot of good properties. When you make a subclass of mobster, it depends on subject, but it doesn't have to really depend on FBI agent. FBI agent implements this observer interface. Observer is just an interface. Again, if you're a Smalltalk programmer, you don't think so much about interfaces, you think about classes. But if you move all this to Java, then you can see observer is just an interface. The subject would actually be a real class, and there isn't any. It reduces coupling because the subject doesn't know anything about the different subclasses of observer. It just knows there is an observer interface, and it interacts with that interface and doesn't know anything. So it's easy when you're using the observer pattern to create new kind of observers, to create new subjects. You can mix and match them, and a lot of things are made easy. There still is a kind of a coupling, but it's sort of abstract. So there are usually three parts of using the pattern. There is the registration, where you're telling that this observer is going to depend on the subject. You register the dependency. A notification when you realize that something has changed. So you say self-change, you notify the change, and then the update on the observers as they are told that an update occurred. C++ can be done just the same way. We get a subject, an observer, pattern. Here, the way we did in the book, this is update, took a subject as an argument, so you pass along what subject had changed. There's obviously a lot more code that can go. But now, one of the things that happened in Java, the very first version of Java that came out actually had the observer pattern in it, just the way we did in the book. And you can still see, if you go look for an observer, there's an observer interface in the system that doesn't get used. And that's because they very quickly discovered that it didn't work too well, and they built listener. And you think listener, observer, you're trying to do the same thing, sort of the same pattern, but in a special way. And one of the obvious questions is, well, if Smalltalk people did this and C++ people did it, Java is sort of like somewhere in the middle between C++ and Java, C++ and Smalltalk. So why didn't it work with Java? Why did it? Well, I don't know completely the answer to that, but what I think is that Smalltalk, of course, has dynamic typing. C++ is very strict, but all the people who are doing this in C++ were not really trying to reuse this interface. They were building it again for every particular library that they were using. And so what happened in Java is they actually did try to make this be reusable, and they had problems with the static type checking, making it be reusable. What they do, what they're listening is, you actually say, well, the argument to your update is not going to be just some random object. You're actually going to specify exactly what kind of object will be the argument to the update. It will be an event. So we have this event, and you're going to update with an event. And there actually could be lots of different type of listeners. You could specialize this interface, have a number of different types of interfaces. In fact, you can even have more than one update message. So lots of different type of listeners in Java. And a component listener is one that has a bunch of different, and they're not called, these operations are not called update. None of them are called update. They're called something else. Action perform, component resize, component move, all these different names that are given, but they're the same. If you actually look at what's going on, the purpose of this is to notify all the listeners, not observers, but listeners. So it's the same idea. And in fact, I believe that this having a lot of different methods on the same listener is was sort of an experiment that has sort of failed because these were older interfaces. Why don't you see all the newer interfaces that are done with different listener interfaces in Java? They tend not to do that. So again, I don't really understand why they, because I mean, I've used component listener and it all seems pretty reasonable to me, so I'm not so sure why people aren't doing it in others.
Because they have a new syntax.
They have a new syntax? Oh, no, this is even before Lambdas. This is even before Lambdas when that happened. Yeah. And I program in Groovy a lot, and so Groovy has had closures and has a special way of doing listeners that is sort of nice because you don't have to make a new class when you're doing a little special listener. Okay, so the book was making comments. So one of the things when you look at observers, we talk about push versus pull. Those are two ways of using listeners, or observers. With listeners, the same thing. But we're talking about the book. The book is an observer. And two ways of using it with a push, you want the update event to carry all the information necessary so that the observer gets notified of this update and it has all the information it needs. It doesn't have to go back to the subject and do anything. So that's what a push is. Pull means that when it gets notified, it will go back to the subject and read the subject again. So you get two messages. You get twice as much traffic. In a distributed system, you really want to push, you don't want pull. If it's all in memory, pull actually works pretty well. It doesn't make a big difference there. It's sort of two different styles. Okay, so talk about this. The book says, avoiding observer-specific update protocols, the push and pull models. Implementation of the observer pattern often have the subject broadcast additional information about the change. The subject passes this information as an argument to update. The amount of information may vary widely. And then a little bit later it says, the pull model emphasizes the subject's ignorance of its observers. So the pull model, that means that when you're notifying your observers, you know nothing about these observers. You don't know what they want. You don't know what they want. You say, I change, and you better figure it out. You don't know what they want. Whereas the push model assumes subjects know something about their observers' needs. The push model might make observers less reusable because subject classes make assumptions about observer classes that might not always be true. Now, this is a secret to reading. When you see that a writer starts saying might a lot, that shows that they don't really know what they're talking about. They're sort of guessing. And so we have here that might make observers less reusable. It's actually sort of logical. What we say here is logical. Unfortunately, it's not true. Exactly the opposite is true. The push model actually makes things much more reusable. Okay, so this is what we've learned since then. The push model can actually make observers more reusable. That's what part of what listeners give you by having specialized observer interfaces for particular kinds of change. So we have a mouse, and how can the mouse change? And when you look at the mouse, I guess none of these are mouse listener, but when if a mouse changes, buttons going up or down, or the mouse moving. And that's basically all that can happen. So if you say mouse move, you then can ask, well, was it up or down? Did the button go up or down? Which button was it? Or was it a movement? And those are your choices. Those are the only ways that they can change. And when you talk about a change, component change, what you always want to know, if the component moves, you want to know where did it move from and where did it move to. But if you know where it started and where it ended, well, you know all that you need to know. So you actually can bundle that information up in the event, send it out, and by having the specific event, you could get a push model with, so that means that in a distributed environment there's less traffic, which is important. And it also means that you can have these specialized observer interfaces. And when that happens, the result is you want to build a library of components for that. So a single interface, here are 2 or 3 or 4 or 5 components that implement that interface. And so now you can build a user interface more by composing parts. You don't have to make new classes, you can compose existing classes. So it leads to more reuse. And there's a term, some Java libraries use this term, I think they all use the term data binding. I use Vaadin, D-A-A-D-E-N, I believe, and it calls it data binding, or this sort of idea, where you have these different interfaces. And then what you do is you say the model will be a kind of a composite model, that when you build your model, the different variables are holders, and then you make a view that looks at a variable. So by a holder, sort of an event, it's a subject. So you have your big model has little subjects in it, and you can look at just this subject or that subject or that subject and get the change. You don't assign to a variable, you set the value of this property of the subject. And just in Smalltalk, there was a commercial system called VisualWorks, and in 1994, they had been doing it this way for 2 or 3 years. I think 91 was when they came out with this whole way of doing things. So I was very familiar with it, and why we didn't talk about that in the book, I do not know. But you end up with a window like this. It's got these different, each one of these is a holder or a property, or, I mean, the system I'm using, they're called properties, and holder was what they were called in VisualWorks, which is why I keep using that. And then you have windows here. So this would be a list or a string text editor, string view, and that would be a list view, and so on. Okay, so the advantage of this data binding is that you don't have to invoke update events explicitly. You don't have to say self-change. You just assign to a property, and the property automatically tells everybody that it changed. Now, that actually is not that big an advantage, because that's not the buggy code. That stuff is easy, and then, yes, we've automated it away, but you know, it's a nice little bonus, but it's not a big deal, really. The bigger deal is that observers can be reused. And so now you build a library of these observers, and so then you get a big benefit. So when somebody comes and tells you we're going to use this pattern and it has this big benefit, it actually doesn't have that big benefit until after you've built the class library for the components, which might take quite a while. But it is true, once you get there, then it is a component. And you've got to have these standard interfaces. Okay, so a classic problem when you build these things is that you've got this model with little submodels, a big subject with little subjects inside it, and you build a window, and each subview depends on one particular aspect, one particular property. But then you have these interesting activities that take a whole bunch of properties. It's going to affect a lot of properties. So what I have here is when you select a new file name, you're supposed to go read the file and then display the text in the lower box. So the part in the middle is supposed to be a list of file names, and you select one and instantly you see new text down below. Well, you can't do that with one window. That is, all these windows are talking to each other, and if there's from some library, then they're not going to have that built in. So what we do typically is, whoa, what did I do? Oh, that's funny. Okay, What we do is we use a mediator. You pick some object somewhere, and if you're building, you got this hierarchy of models, you might use your topmost model to do that, or it's a hierarchy of views, you might use the topmost view to do that. There'll be some object somewhere, and you'll have that object register itself as a dependent on things that it wants to know about, in particular like this list. So they'll find out when someone selects a new thing on the list. And so it will handle that, that particular case. And that actually is a mediator because you're picking some object to handle interaction between the other type of objects. And mediator is another pattern in the book, which I'm not going to explain too much about here. Other than to say, when you read the book, one of the things we talk about is related patterns. And in design patterns, under observer, it says mediator is a related pattern. So yes, we got that right. But then you go and you read it, and it talks about something entirely different. It was not talking about what I just told you. Instead, it says, by encapsulating complex updates, the change manager acts as a mediator between subjects and observers. So what it's talking about here is that there are times when you don't want you don't want it to be completely distributed, where you worry about detecting cycles, for example. That's a problem that can happen with the observer, is that if you get a cycle of the observers, you get an infinite loop, and that's not good. So instead, you run all your updates through a single object. You have an object that gets told, I am updating this, and then it will trace through the graph and make sure everybody gets notified and it can catch certain errors. And we've seen several of them. A lot of people have done something like that, and that's a kind of mediator too, but it's a completely different kind of mediator. And that was the one we talked about here. So in fact, the book missed, I'd say, the most common use of mediator, because pretty much every user interface will have some place you're going to just have to have somebody just respond to these events that aren't being handled automatically by the library. Okay. I'm backing up. Microsoft has come out with several pattern books. There's a group called Patterns and Practices, and they're a documentation group. They actually hire outside people to write books most of the time, although they have written some books with people inside. And they're usually free. You can get free copies of them. And obviously they're trying to teach you how to use all the Microsoft technology, but a number of these pattern books will have divide up each pattern into one section that is fairly independent of technology, and then the next section, the last half, is very specific to Microsoft. So you can actually just read the first half and apply that to whatever. But one of the things they do, at least in some of the books, one of the things they do that they really like is they tell you for every pattern things that can go wrong. How do you test a program that uses this pattern? And that's a really valuable thing, which we should have put in our book too, but of course, that was 22 years ago. We weren't thinking that way. And probably didn't even know then. But with Observer, it's a lot easier because with Observer, you could either bad update method, you could miss a call to change, or you could miss registering things. And my experience after many, many years of programming these things is that it's the first two bad update methods, you discover them right away. And so they are very easy to spot those problems and fix them. And missing a call to change, what happens is you do something over here and you expected that to update and it didn't. And if they just forgot to do a call to change, it's pretty easy to fix. But sometimes a lot of stuff is changing, but that one isn't. And that's because they forgot to register. And the registration bugs are actually the hardest ones to find in my experience. So those sort of things are good to know when you're using a pattern. Okay, so now I'm going to switch and talk about iterator. I'll actually come back to observer. Talk about iterator. So iterator is one of those patterns that almost everybody, when they read it, says, oh, I know that. It's it's one of those patterns that if you're learning Java, say, they'll probably teach you in your first programming course. Because, and the basic idea is we have an iterator object, but we've got some aggregate, so that's an object that has a lot of structure, and then we have an iterator that is this interface of how you iterate over some structure. And so we ask the aggregate, give us an iterator for yourself, and then we can iterate over its components. And the book talks about the difference between external and internal iterators. So in Smalltalk, you learn about the collection classes, and you say do on a collection rather than getting the first and iterating by hand. And that's a kind of iteration too. That's one of the things. That's called an internal iterator. So C++, back 20 years ago, you didn't have internal iterators. It had to be external iterators because you need closures or something like that in order to do iterators. And so we talked more about external iterators and internal iterators. I'm showing you Smalltalk. You can iterate pretty easily over, if there's a string and we're iterating over the characters in a string with a do operation. But you actually could have done that with an external iterator too, because this is a fact. Internal iterators are handier. They are more succinct. They take less space. They're easier to reason about than external iterators, but they're also less powerful. There are things you can't do with an internal iterator. You can do with an external iterator. So here's something you can do with an internal iterator, and you probably be stupid to do it with an external iterator if you could do it with an internal iterator. We make a read string, and then we do while false on the read string, and read the characters one at a time, and then do the same thing of checking if it's a valid or not. But in fact, Smalltalk has other operations, not just iteration, not just do. Do is your basic iteration. Smalltalk has select, where you return, given a collection, you return another collection that's all the elements of the first one, and you have reject is the opposite of that, and you have collect. Collect gives you a new collection where you apply a function to transform each element of the original collection into the new one. And if you start with a set, you get say collect on a set, you get a set back. If you say collect on a string, you get a string back. If you say collect on a ordered collection or a list, you get an ordered collection back. So whatever type of object you say collect on, you'll get that same type of collection back. There's also inject into, which is cool. It takes a large collection of objects and reduces them to a single element. Now, I'm programming in Ruby. And in Ruby, you see something pretty similar. They, instead of do, it's called each. You say dot each, and then give it a closure, and iterates over them. Collect is the exact same way as it was done in Smalltalk. Instead of select, it's find all. And I don't really consider find all a better name. It's a sort of weird name. Instead of inject into, it uses reduce. I actually think reduce is a better name. And inject into is a weird name. So an important thing about these names, they all rhyme. That's very important in programming languages, right? You go, oh, you got to make your programming languages rhyme so you can wrap them or something. But you know, so some of the names sort of made sense when they got to inject into. They were really stretching, trying to find something that would rhyme with them. Okay, so one of the things is streams. And when I would talk about object-oriented design, I have a class I taught for many years, object-oriented design, and use Smalltalk. And whenever I would come to streams, I would say that streams are external iterators in Smalltalk. And you look at Java, other languages, they've got streams too, and yes, they're sort of external iterators, although usually when they say, here's how to do an iterator, they don't do it quite the way you have streams, and there's actually multiple hacks on streams and different attempts on streams in Java. But one of the things that occurred to me was that since you say do on a stream, you can say do on a stream, why can't you say collect and select on a stream? And you can. What I do is I make a class select stream, and when you say select on a stream, it gives you back a select stream, which is a stream that only gives you the right ones, and collect stream is the same way. A select stream is sort of funny because with select stream, you can say, I want to select every object less than 3. And then you give it a stream, 0, 1, 2, 3, 4, 5, 6. It goes on forever. It's infinite stream. And so that is actually a little tough to implement in normal because it keeps looking to see if there's going to be something less than 3, and there never will be. But still, you can have those. So JavaScript has array. It doesn't have a big class library with lots of possibilities, but in array they have for each and map, filter. So map is the same as collect, and that's actually a pretty good name. I mean, map, and these are sort of becoming the standard names. And there's filter instead of select. And that's not too bad. And reduce, which I say is a better name. So these names were brought in by Java, and I'm sure some other language did them first. Okay, I am 100% sure the JavaScript people did not invent those names. They copied. I don't know where they copied them from. I'm sure they copied them from Haskell. Okay, that's quite likely because Haskell is the sort of language where people spend 3 months arguing about the names should be. And be likely to get good names. So it's a good language to steal from. Anyway, somebody in JavaScript got the absolutely amazing idea to use use it on screens. That's not so amazing. That's sort of logical. But then to sort of use this for reactive programming, for real-time programming, and so. They have a quote as they tell you that they're actually going to apply all these functions and put them on streams. And this is a great line. Event stream has all the array functions, because in JavaScript, map, filter, and reduce are array functions. Even though, to me, they're collection functions. But that, again, this is their JavaScript people, so they would say, event stream has all the array functions because an event stream is like an array, only laid out in time instead of in memory. And that to me is brilliant. That's a brilliant way to think about it. They are laid out in time instead of being laid out in memory. It's an alternate dimension. So Java 8 has brought these into streams. And what the book does not say, even though I think I was saying it in my design class notes at the time we wrote the book, I don't actually keep my notes for every year that far back, so I'm not 100% sure, but it just seems to me that I was. Is it a stream is a kind of iterator? And something I think is very important is that it's not just the basic iterate function that's important, but we want map, filter, and reduce, and other things as well. But map, filter, and reduce are the basic ones. We want them, you actually can define them on any iterator, even if it's an external iterator, even if you don't have closures in your language. But I've done that, and it's pretty ugly, which is why people don't do it, because they, I think that actually there's a C++ library, the big collection, like, what was that, I might have the name for that library.
STL.
Excuse me? STL, yeah, Standard Template Library. I think the Standard Template Library actually has these in it, but it's pretty messy. But when your language has closures, it changes things. Then you reach, of course, all the languages that we're seeing are going that direction. Okay, so why do Smalltalk programmers use collect and select? They do that because it makes their programs simpler and easier to read. You can have pieces of code that look like straight line code, even though there's all these loops in the middle. From a practical point of view, I mean, from a machine point of view, there's all these loops in the middle, but when a human reads it, it looks like straight line code. Easy to think about once you figure out how to think about collect and select, which takes a little bit of work. You have to train yourself to think about collect and select, but then after a while it becomes pretty easy. Even injecting two becomes easy after a while. That's usually the last one to become easy, by the way. But it turns out that you can do parallel programming with these too. Not in Smalltalk, of course, because but there are some of the GPU languages that actually want you to program this way. So when you and generally parallel programming is hard. Parallel programming makes things harder. So here's a way of programming that we claim makes things easier, and it's good for parallel programming. So that's actually pretty unusual. But if you're doing the MapReduce packages, they're doing the same thing. There's lots of places it's coming. So if you have an opportunity to program like this, practice it. That's how you get good at it, and it applies all over the place. And we should have said that in the book, and we didn't. We did not say that in the book. Okay, so now I want to talk about reactive programming, which is this really, really cool thing, which has been invented, I don't know, 5 or 6 years ago. I mean, it was not around at all. I don't feel guilty at all for not having talked about this in the book because nobody did it. But the idea is you think of a subject as an event stream, and now an observer will be a function on this event stream that transforms it into something else. And it has advantages of, actually for a lot of simple programs, it doesn't give you any advantages, you know, that you've already got it, but when you do things complicated, then it starts to give you advantages. So if you had to keep some state in your user interface to deal with odd conditions, that sort of thing, for synchronization gets way easier, error handling gets easier, and you get fewer race conditions. So they add a lot of operations to strings. So they take the ones I've talked about, but then they add operations like concat all, which is not that unusual. It takes a list of lists or something and concatenates them all, so you get a single list. And take until, this is an interesting one, take until another string. Something like collect and select are deterministic. You run them, two cases in a test. You run them in a test, you always get the same answer. But take until is sort of funny because it's on a stream and it's got this other stream, which is a stop stream. No events come in the stop stream. So it just runs on the first stream as fast as it can, pulling events off until suddenly an event comes in on the stop stream and then you stop. Okay, so how many things return from a take until? Who knows? It depends how long it takes before somebody does something on the stop stream. So it's absolutely non-deterministic. That's its whole point, its whole reason for being is to be non-deterministic. So that's the people who do this. So here's a JavaScript. I've never actually written and run a JavaScript program. So if there's bugs in my JavaScript here, I'm sorry. But I was copying this from somebody anyway. So what we're doing is defining. There's a little piece of code down here that's going to use this function getElementDrags, and we're going to define the function getElementDrags up there, and then we're going to use it down here. So that's what we're doing. And this is JavaScript, the newer JavaScript notion. We're defining a function that takes an element, and so getElementDrags is a function that takes an element and then does it. So what it's doing is, and this document is in document. There's supposed to be element. I don't know how I need to fix this slide because anyway, we do mouse downs. That gives us a stream of all the mouse downs on the element. And then for each mouse down, we're going to get a list of mouse moves on that element. And it does take until the mouse moves, until the mouse comes up. So as soon as the mouse comes up, you get an event on that, then that stops. And so now we have a sequence of the mouse movements. It's a sequence of points. And you do concat all to get all, so you can do mouse up and down and concat them all together. And so now we're going to get a list. Get element drags is going to get a list of all those points. And so for each point, there's the point, and we set the position of the image to be that point. So it moves and follows the drag. And this is funny because it all seems very static. It all seems very static. What's actually happening is, as you click the mouse and move it around, the system is finding this point, setting the point to cause the image to get moved around on the screen. And that's what the idea is, that you don't need to have this synchronization code that's worried about, does this happen before that, and you sort of lay it out statically. So I think it's a very cool reactive extensions. It's a very cool extension to observer pattern that has become popular the last few years, and they've implemented it in a number of libraries. Netflix is big on this. I think it actually came out of the Microsoft group, but Netflix are the people who publicize it the most, and people are putting it into lots of different libraries. The libraries of different languages. Okay, so I want to just summarize. There's a lot of things about the observer pattern that could have been improved. One is, I think, a listener, that we pass events as arguments to the update, and that leads to multiple observer interfaces, each specialized. When you have a bunch of observers interfaces, all specialized, you do is data binding, where you assign, what you're doing is setting a property, and you actually are observing the property. You let these properties be your subjects, and you have a lot of different observers, a library of different observers to look at those properties. How mediator gets used, we should have talked about that classic use of mediator, and I said something about adapter, but I got rid of the slide for that. So, and then this simplified complex observer logic by treating event streams as iterators and using collection operators like map and filter. And again, the last one, there's no way we could have seen that. But I actually think we could have had some of the other in the book back then. It was, I had seen examples of that. I don't remember arguing about it and saying, no, let's not put it in. There's nothing like that. We didn't think about it. And for iterator, we really want to say there's more operations on iterator, not just, and this one, we might very well have talked about that and said, yeah, but our readers are mostly going to be C++ programmers. This would all be over their head. It's sort of too hard for them. Although the standard template library proved that wasn't true. But the standard template library came out like a year after our book. So if it had come out a little bit earlier, if our book had been later, maybe we would have included that, because the standard template library did that. And the fact that streams are kind of iterators, we should have said something about that too. And I'm sort of running late, so I'm going to skip over that. This time do I actually go a little longer? Okay, so I'm going to talk a little bit more about the composite pattern. And the idea behind the composite pattern is that you're building up a tree of objects, and you want to have this abstract component idea. You can plug a component into a component and build up a big tree of these things. So a straightforward, one alternative that's pretty common, is not quite the composite pattern, is that you say, well, every component can have this possibly empty set of components. So if you have done a squeak, morphic does it that way. Every morph can have a list of submorphs. And the first molecule controller in the original Smalltalk 80 did it that way. Every view could have a list of subviews. But they don't do that anymore because that turned out to be too easy to make mistakes. There are some of these objects that are going to be leaves of your tree, and they should never have children. And the poor programmer may not know that, and it's really easy to just add a child to something that's not supposed to have a child, and then usually you get bizarre behavior, and it takes a little while to figure out what's going wrong. And then the experts are going, oh yeah, you shouldn't do that. But it's just as part of the learning curve. It's unnecessary. Why did you even make it so that these objects that never should have a child have an empty list of children? You can easily add another child onto it. It's just asking to be misused. So what we do instead is we say that we have our component class has different roles. Some of the subclasses are leaves. Some of the subclasses are composites. Sometimes you have a single composite class of subclasses. Sometimes every composite is just a different subclass, a different way of doing it. It's still the same pattern. And the component class then has an interface. It sort of defines the interface. You really would like all your leaves and composites to have the same type of interface. They should all act like components. So you can use them, mix and match them, so that clients don't need to care. Am I getting a leaf or am I getting a composite? Whatever they get, they can process the same way. That's what you want. But what everyone discovers when you do this is that if you really want to say that leaves can't have children, what about the add child operation? What do you do if you do an add child on a leaf? What do you do if so children do? You want to iterate over the children. That's actually easy. You can iterate over the children of a leaf very, very fast because they have no children, and so you just hard code that to return the number. So that part you can handle. But what about add? And people scratch their heads, and they try this, and they try that, and it's just sort of this unsolvable problem. I actually had somebody who read our book and came back and said, oh, thank you for the book because I thought I was so stupid that I couldn't figure out a problem, figure out a solution, and what you say is there is no perfect solution. So I feel so much better about that. But what we say, but given all that, you have to put it somewhere, and should you put add and remove in the parent, in the component class, and then you have to implement it in leaf to cause an error? Or do you put it in composites, have the interface be just a little bit different? What should you do? Those are your two choices. And there's no perfect solution. If you put it down to child, you actually do have to test sometime as to which one you're going to use. So the book says, this is an important issue, and it basically says the only way to provide transparency is to define default, is to define it in composite, and then define default add and remove operations in the component, which will give you error messages. So that's what we say. So we basically say put it up in the superclass and keep them with the same interface. Now, I argue against this because this is not how Smalltalkers do it. Smalltalkers put it down in the subclass and they ignore the superclass. The C++ programmers back in 1994 were doing it this way. And there were like 7 or 11 class libraries that we looked at, and C++ libraries are pretty much all doing it the same way. So we went that way. Now, it turned out that within a couple of years, C++ libraries started to change their minds because they added the type-safe downcasting to C++. And once they had that, then everybody shifted over to we'll do a type test, see whether or not it's something that has the add operation or not. And so, in fact, that little language feature had a big impact on how you do this. But we didn't say that in the book. So now we sort of believe we should put add and remove in the composite, not up in the component class. So it should be in the child class rather than the parent class. And you use this type safe downcast when you want to add or remove. And as I told the people in Smalltalk, of course, I remember this really well because this is one of those times when I lost the battle, and yet I was right. And you always remember those. You always remember those. It could have been the only one, by the way. I can't actually think of any more, but it's quite memorable to me. Okay, so that gives you sort of a sense. As you go through every single pattern, you can find something where we could have done better. It was 22 years ago. We actually had hundreds of people read the book before it came out. And so, I don't know what, we had something like 50 people give us comments on it, but we had mailing lists that we put PostScript files out to FTP servers and people. That was the latest technology back in 1994. Because the World Wide Web basically came out just like that year or the next year. So that shit tells you something about what the world was like back then. Java came out the next year. So if we see 95, you might think, oh, Java came out before, but Java came out afterwards, except that the Java guys there were some of the Java guys were on our mailing list and were reading stuff. So Java is actually the first language where the people who made the class library had read our book. Now, that doesn't mean that they learned the patterns from the book. These guys were really experienced people. They knew the patterns already. But because they read our book, they used names in the book. And so, that's sort of nice being able to see the names, you can spot the patterns real fast that way. Okay. Patterns do change, and new things come out, and things like the concurrency for the combination of iterator and observer. And really the point about, emphasize this thing at the bottom, the point of learning patterns is not to learn patterns. It's not that the patterns themselves are magical. They will work in some systems and not work in other systems. The point is we're trying to build systems with good design. And the patterns are ideas, they're things that have helped other people make good designs. So odds are good, they'll help you make a good design, but they're not guaranteed to do that. But learning them, the question is, well, why were they helpful for these other people? When you learn them, you learn principles of good design, which will carry over. And some people say, well, what's more important to learn, principles or patterns? Well, obviously, principles are more important than patterns. They're also way harder to learn than patterns. Patterns are sort of a discrete thing that you can learn, and you can copy it, and you can follow it, even when you don't quite know what you're doing. You can get in trouble that way, of course, and you will get in trouble that way, but at least you're making progress. You're doing something, and you're practicing the right sort of thing. And when you learn that, oh, I shouldn't have used this pattern over here, you've actually learned something that's valuable as well. Okay. So this is my email address, and I always enjoy getting email from people. So that is my talk for today. I'm happy to take questions. Questions? Yes.
Can you hear me?
I can hear you.
My question is about the MVC ideas. What do you think about the MVC?
About model view controller?
Yeah. The relevance it has in contemporary software development.
Okay, so model view controller, I think of model view controller as there was in the original Smalltalk. And then there have been these various web frameworks, which are also called model view controller, and they're really different. For the original model view controller had observer in it, and you can't really get observer in HTML. So the web ones didn't use an observer. So right away that says to me it's a different thing. Now the motivation of separating the graphics display part from the control, the logic part. That has the same motivation. So they're just trying to figure out how to do it using this particular technology. Now, if you're building some reactive environment, it's JavaScript running in their browser, and there's a server back over here, and so they're communicating with it. What exactly is the model? Is the model inside the browser, some object that you're doing in the browser? Is it the object over on the server? I think it's probably actually the object in the browser, and then you have views that are going to be depending on it, and that's going to actually look an awful lot like the original Smalltalk model view controller. So I think the idea is, there are other things. Model view controller is for a particular case, and there are lots of times we're building something that doesn't match that case. Well, fine, if you're actually trying to do a robot or something. You're not going to be doing, maybe if you have a user interface for watching the plan that the robot is creating as it goes along, that might be more of a model view controller thing. But the robot itself, there's nothing in there about model view controller at all. And if you think of games where there's some world model, and that's changing, like every half second. There's some thing that goes, and so when you click on something, it sends out a little event, and it takes a list of all these events, and every second or half second, the system comes around and sweeps through and does all these things at once. That's not very much a model view controller either. It's a different, but they need it because it's multi-user, and how you deal with the performance issues. All the stuff, doing it in a model view controller way would be incredibly expensive for that, so you didn't do that. So the point is, it's an architecture, and there are places where that architecture still works, but there's lots of places where it doesn't work, and it doesn't mean it's bad. So when I am teaching, one of my teaching design and software engineering, one of my complaints is people's idea that if you're going to store some data, have a database, you've got to have a relational database. Well, a relational database is important technology. And there's some places where it's really great, other places it doesn't work all that well. Some types of data doesn't work too well. And even when you use it, though, you end up spending a lot of time fighting and trying to get good performance. Now it's how much memory does this use? Oh, it's huge. It's back in the day they say it's several hundred megabytes. And even back then, there's other ways you can do it. And nowadays, when your computers have gigabytes on them, why not just keep it all in memory? Why do you have to store it on the disk at all? Once it's in memory, suddenly your performance problems just disappear. It's all so much easier when you keep it in memory. And again, it doesn't mean relational databases are a bad idea, just because people use them in cases where you didn't really need a disk-based database at all. It just says you need to know when to use it. You need to have a lot of alternatives. And that's a lot with patterns. Patterns are knowing different alternatives, knowing different design techniques. So when you come to a problem, you can try out in your mind, I'll try this, I'll try it, and figure out which ones are going to be best for your system. So model view controller is still relevant. I think there's a lot of people build systems that don't need it, and some of them probably use it when they shouldn't use it. It's always the way. But there's still places where it's relevant. Yeah. Yes.
What do you think about the decisions in the Smalltalk community that decide to implement collections as emergieron, not by the behavioral structure, but the physical structure of the collection?
Okay, I'm not quite sure I understand your question. So I understand what you said. What you said was, what do I think about the decisions in the Smalltalk community to implement collections, not so much based on the interface, but rather on the implementation. So you're talking about like set and dictionary, the fact that that dictionary is a subclass of set, but really all it's doing is reusing the hash table. So one of the things about, there are these principles like the list of substitution principle, which that violates, by the way. And people will take these principles and they will say, when you write code, you must always follow these principles. Now, I actually don't think that's true, because one of the alternatives you're trying to do, if what you're trying to do is hack out a quick solution so you can meet your demo date, or you can convince your funders to give you $1 million on next Friday, it doesn't matter anything you do to get your code out there fast is fine. And if you think of the sort of the XP life cycle where you take a test and just do whatever to get that test to work right, copying code is a great way to get a test to work right. But then you're supposed to refactor afterwards. You're supposed to clean up afterwards. You shouldn't mistake that kind of programming for clean code, for good code. And it's okay to do that, especially if you clean up after yourself right away. It's one of those things. It's hard to bake a cake without breaking eggs. It's hard to cook without making a messy kitchen. But you can clean up after yourself. And that's sort of so. What we see there is actually we used to have a decision by the Smalltalk committee, and that is actually not true. What we are looking at is a decision by somebody back in the 70s, and that because that's sort of it's got this stuff that works, people have just sort of kept it. There have been people who have shown, well, we can do this better, and here's how we can redesign it. In the 70s, it actually made sense because they were running on computers with like 64K of memory, and you had 16-bit objects, and they had 2 to the 15th object pointers that were allowed. And having your collection be one single object rather than splitting it into a hash table object and then the set that wrapped around it, or a dictionary that wrapped around it, which is really the way it ought to be. Saving that extra object was really important because they had thousands of these collections in their system, and they would run out of objects if you did that. So when they did this originally, it was actually a very clever thing, but it's not a clever thing anymore. I don't know why they don't fix it, other than it just being conservative. That's the way we've always done it, so we just keep on doing it. But I've been sort of lecturing on this as being a suboptimal design for quite some time. Okay, it'd be a fine thing if it was what you were doing in the middle of some project and you're going to clean up after yourself, but it isn't. Everyone's been using this as a standard for 40 years. We should have fixed it by now. Yes?
What do you think about strategy and state in some process?
Strategy and what?
State.
And state. Well, that's interesting because I'm giving that in my talk at FLOP this week. I'm using those as my example. So strategy and state are interesting because when you look at the diagram in the book, they look pretty similar. When you read the intent, that little paragraph, they look completely different. And so then the question is, well, are they similar or are they not similar? Now, partly the book doesn't say, like, what's the key parts of a state, what's the key part of a strategy. So, well, it does say, for the strategy, it says you're having a family of algorithms. And so you need to have a common interface. You have to find a common interface for all these algorithms. It's pretty typical that that interface is a single method. Not always. You can have strategies with 3 or 4 or 5 entry points. That can be done, but it's pretty common that strategy has just a single method. State does not make sense to have a single method, because the whole idea is you have one state machine that takes certain type of events. There will be, unless there's only one kind of event, that you'll have a method for every kind of event, and you'll have a subclass for every state. So, part of them is there's a different story that goes along behind them. But the fact is, the code can end up looking pretty similar. If you're coming to a system and you haven't been told whether it's a state pattern or a strategy pattern, it's not just the case that it might take you a couple of minutes to figure out which it is. It might take you, you might stare at it all week and still not be sure. It's sort of halfway like a state, halfway like a strategy. And our famous case for that is in the hot draw text editor, the buttons for creating new. Anyway, there are cases where you can actually say it looks like half one, half one. Yeah. there's a great book, sort of a linguistics book. It's a linguistics book, actually, although sort of a philosophy book. It's a great book for people who really want to get into object-oriented design. It's called Women, Fire, and Dangerous Things. And the author is George Lakoff. And he was a linguistics professor at University of Chicago when he wrote it, but I think he moved to Berkeley afterwards. Anyway, he's written a lot of different books. And the early part of his life was looking at metaphor. It was looking at metaphor and how we come up with these things. How do we decide that things are in the same category? There's apparently some island where people have different categories, and one of the categories contains women, fire, and dangerous things, which is why the title of the book came. And he looks at, like, some of it is from our body. When we get mad at somebody, we feel hot. And so every language has in it the idea that becoming mad is like fire, it's like heat, because our body teaches us that. I suppose squid, if they talked, they would have different metaphors, because they think about being mad as blackness, because the ink comes out that you're expressing it. Whatever, but because we're human, we all think of anger and heat as similar. But he talks about how we say that two things are similar. And go back to Greek philosophers. You've got Aristotle versus Plato. And so Aristotle said that the way that you know that two things are similar is that you ask questions. You say, is it like this or is it like that? And you have a key. You have a set of questions you ask, and that determines if something is this or not. Whereas Plato said, no, it's because we notice that something is a chair. Because there is, up in heaven, there is this essential chair. And that chair sort of projects down into earth, and that's how we get our idea of a chair. And of course, we read this today, and we say Aristotle seems pretty reasonable, and Plato is nuts. But he says, no. Plato is right, and Aristotle is wrong if you understand it properly. Because what actually happens is that we have an idea in our mind of what the perfect chair is, and so when I was lecturing and talking about this, we were in a place that had 100 seats, and there was a table, a bench, a table, and then all these seats were attached to an iron bar underneath. They were not individual chairs. These are clearly chairs. So everybody would agree that these are chairs. So I asked them how many chairs are in the room, and they would quickly look around and say, 100, 110, 100 something. I said, no, there's two chairs. The one I was sitting in and that one over there, those things are not chairs. Those are benches, or because to say something is a chair, but you thought it was a chair because it was clearly for one person, but they all were on a single bar. And what is a chair? We're talking about a beanbag chair, right? That is so different from a regular chair. But when is something a sofa, or we have all these different words for different types of furniture that you sit on, and how do we distinguish between them? Well, and that is that we say things are simple patterns. Getting back to patterns. What happens is we have this ideal of a state pattern, an ideal of a strategy pattern. Code is not the ideal. Code is a little bit different. And so you can say, well, what if something is just a little bit different from, it's mostly like state, but I've changed it a little bit more like strategy. It's no close to this state. It's clearly a state. And then what if you change it a little bit more? What if you change it a little bit more? Well, finally you get to the point where you say, oh, now this is clearly strategy. But something could be right in the middle, and when it's right in the middle, you scratch your head and you say, I don't know, is it state? Is it strategy? So we say, I know what I'll do. I'll come up with a new pattern. We're going to call the thing in the middle something new. And now we've got a name for this. But the problem now is, before this thing was clearly a strategy, but now it's sort of halfway in between the two things, right? And so we're not really any better than we were before. But this is, you see this every field where professors are out there giving names to things, or I mean, it's a philosophical part of categorizing things, because the world doesn't actually have these neat little boxes that stuff fits in. And the world doesn't fit into our patterns perfectly. You know, systems are the way they are. The patterns are our attempt to describe it. And as long as we realize that, and we realize our attempts at describing are always imperfect, you know, they're very useful. They're very useful. They aren't a perfect description of it. So that was probably more explanation than you wanted. Yes, back there.
Thank you for this talk. My question is, if you were about to write design patterns today, which patterns would you choose to be in the book, and which others wouldn't be, or which new ones would you put?
Well, we actually made a plan for this whenever we met, which was a long time ago. So we were actually going to put all the patterns back in. We're not going to take anything out, mostly because if you took, there'd be somebody who'd get mad for any pattern. And even if what we want to say that this isn't really a fundamental pattern, you have to put it in the book so you can say that. But we wanted to spend more pages on the really useful patterns and less pages on the one that aren't so useful, so you can sort of adjust things like that. And we did have a number of new patterns we wanted to put in. So I mentioned null object as being one. I wanted to talk about dependency injection as a creational pattern. Because it's actually changed. A lot of the patterns, the creational patterns, get used less than they used to be because people have sort of used dependency injection instead. And we wanted to value object, right? A value object as a core pattern. So I have a list someplace, but that's pretty much. So we're mostly going to just be the pattern. And the thing is that there's a large number of really interesting patterns out there, but they aren't the sort of core object design. This is really about object design, so we wanted to stick to those patterns. Yes?
Yes. You talk about how new libraries that were applied in time changed the way we can think about patterns. But I think I want your opinion about how the emergence of new language constructs can modify the white patterns. The white patterns are so.
So I missed the key part of that question.
What do you think about the impact that new language constructs? I am thinking about the particular mixes or traits.
Yeah.
What's the impact of that in the way we think about it?
Yeah. So new language constructs can have a very big impact. And it's hard to predict what they're going to be beforehand. So we can see them after the fact. So we knew when we wrote the book that having Smalltalk having blocks in the language, and we had seen lists and the scheme with closures, and we could see that had a really big impact on languages. And we mentioned that a little bit. Getting back to state versus strategy, for example. Some people say, what do you need strategy for? Just pass in a closure. If you want to parameterize your algorithm, have the algorithm be, when you need to call the algorithm, you just call this closure and you pass that closure in. Now, what you lose is that frequently when you have a bunch of strategies, you will have some abstract algorithm, and then there's a lot of code actually up in the superclass. And now the subclasses, they just define a little bit of code to specialize it, and you get your variations on your algorithms. You won't get that from doing it just with closures, but actually, they're sort of right. I mean, I've seen a lot of cases where you have your strategy hierarchy, and there's only one method that gets defined on each strategy, and it's usually just 1 or 2 lines of code. And why do we have to build a whole class hierarchy for this? Why couldn't we just pass in a closure for that? It would have made just as good a sense. So in that case, the strategies were there, the class library was there, because we didn't have closures in the language. But and then this gets back to strategy versus state, because the kind of strategies you can do that way don't look at all like states, right? That's sort of the idea where we're going to eliminate state and we just pass a closure in instead. Doesn't really make sense. So that's sort of an interesting, but the fact is that having closures in the language changed a lot of things. The Common Lisp people never liked our book, because they said, half the stuff you do is just trivial, like one line of code stuff. Well, yeah, you program everything in Common Lisp, but that's a different language. Now, their whole idea of an object is sort of different. We're taking the classic approach of what an object is, where sending a message to an object, you send a message to an object. There's one special object, whereas in Common Lisp, you can specialize, have methods based on the types of all your arguments. So multi-methods, they call them. And there's a lot of different things that are different. If the language gets different enough, your patterns are going to shift a lot. And what's interesting is that the patterns that we came up with actually fit a range of languages. Now, I've done programming in assembly language. Can't remember using a single one of these design patterns in assembly language. In Fortran, now the latest version of Fortran actually has objects in it, so you can actually do. You're programming these different languages. You don't use those patterns. You use different patterns. And so you change the language enough. And what's interesting though is going to something like to Java, where you say, well, Java's hardly any different at all. Java's, like I said, sort of halfway in between. And even there, you can get differences in how we use the patterns. So it's sort of hard to predict that. Yes? So which patterns? I couldn't hear the rest of it.
Which pattern follow a good MVC model?
So which patterns were used for the MVC models, as you're saying? So in design patterns, there's a little section where I take model view controller apart. I say that model view controller is the relationship between a view and a model is the observer pattern. That a model is the subject and the view is the observer. But then views themselves are given a hierarchy. It's a composite pattern, except like I said in the very first model view controller pattern, it was almost but not quite the composite. But by the time we were writing the book, they had redesigned it. The controllers act as strategies. They are essentially event handlers. Now, you say that this is a case where strategy versus state, because sometimes a controller has complicated state. If you're actually switching from one controller to another controller, then it looks more like the state pattern. But that's pretty rare. That's usually not done in Smalltalk libraries. So anyway, model view controller is sort of a complicated thing. And my experience is that if something is too complicated to understand, it helps to break it down into small pieces. And for object-oriented systems, at least some of the pieces will probably be design patterns. So there may be some other pieces. When you break it down, you may end up with some patterns you need to talk about that aren't in the book. That happens very frequently. But now, again, model view controller on the web is a little bit different. So I'm not nearly as much of an expert on that, so I won't describe that. Yes?
Okay, last question, okay.
Do you think it could be abuse of pattern in some solutions? An abuse.
So which patterns are abused the most? Or are you saying, of course patterns can be abused. Everything can be abused. Now you can poison yourself by drinking too much water. So everything can be abused. So to say, well, this is abused, so it must be bad. No, everything is abused. That doesn't mean everything. So that's not really an argument. You need to, from a point of view of an author, when we see a lot of people abusing something, then that says that we should have written some warnings. Okay, so for example, the singleton pattern gets abused a lot, and we should have had more warnings. I actually rewrote that pattern some years ago to put a lot more warnings in, so you can see when it should be used and when it shouldn't be used. But just because something gets abused by somebody doesn't mean it's a bad pattern, but it often does mean that the way we wrote about it did not include the warnings that it should have had.
Well, thank you so much for hay un curso en posgrado, en las aulas de posgrado arriba, sobre patrones de seguridad, que lo va a dar Eduardo Fernández, que trabaja sobre esto hace mucho tiempo